Hey everyone, and welcome. Today, we're going to talk about something we all feel constantly, but maybe don't fully understand. We're talking about the wind. So let's pull back the curtain and explore the science behind this incredible invisible force.
So, let's start with the big question. The wind we feel every day, what is it really? How do we get everything from a gentle little breeze all the way to a raging hurricane? Well, that's exactly what we're here to find out.
Okay, let's start this journey at the very beginning, the fundamental definition of what wind actually is. This is the foundation for everything else we're going to talk about.
It's actually super simple. Wind is just air flowing from an area of high pressure to an area of low pressure. A great way to think about it is like water flowing downhill from a higher spot to a lower one. Whenever there are pressure differences in the atmosphere, the air moves to try and balance things out. That movement, that's what we call wind. So on a global scale, there are two main reasons for these pressure differences. First up is solar energy. Think about it. The sun beats down on the equator, heating the air. That warm air gets lighter and rises, creating a low pressure zone. Meanwhile, the poles are cold, so the air there is dense and heavy, creating a high pressure zone. The second cause is the Earth's rotation. That air moving from high pressure to low pressure doesn't travel in a perfectly straight line because our planet is spinning. This is called the Coriolis effect. Basically, it means the spinning Earth causes the moving air to curve. So you put those two factors together, and that's what creates the massive wind patterns that circle our entire planet. All right, so now we know what wind is and how it gets started. Now let's look at the different faces of wind. In other words, all the different types you can encounter.
You know, when scientists talk about wind, they use a few key factors to describe it. They look at its speed, how big of an area it affects, the kind of force or impact it has, and even the region where it comes from. Let's look at short-duration winds. A gust is that sudden, brief increase in wind speed that only lasts for a few seconds. But a squall is a little more persistent. It's a strong blast of wind that lasts for about a minute or so.
Next up is the one we all enjoy, the breeze. This is that soft, pleasant wind that feels so good on a hot day, the kind that just gently rustles the leaves in the trees.
Now, when things get a bit more serious, we're talking about a gale. This is a very strong and very fast wind. It's powerful enough to break branches off trees and maybe even cause damage to roofs. And this is the most intense face of wind. Hurricanes, typhoons, or cyclones, these aren't just winds. They are massive, organized storm systems with incredible destructive power. The different names simply depend on where in the world they happen to form.
Now this is a truly mind-blowing fact. As powerful as the storms on Earth can be, the strongest winds in our entire solar system are actually on Neptune and Saturn. We're talking about winds that blow at thousands of kilometers per hour. It's just incredible to even think about.
So we've learned a lot about this invisible force. Now let's take a look at how meteorologists and scientists actually go about measuring the direction and speed of the wind. Okay, here is a very important point that a lot of people get wrong. Wind direction is named for the direction the wind is coming from, not blowing to. So, if a weather report says there's a north wind, that means the wind is blowing from the north, heading towards the south. That's a really key detail to remember.
You've probably seen a windsock at an airport before. It actually does two jobs. First, the direction the sock points tells you which way the wind is going. And second, how horizontal the sock is gives you a pretty good estimate of the wind speed. The straighter it flies, the stronger the wind. But for a really precise measurement of wind speed, scientists use an instrument called an anemometer. Basically, the wind catches in those cups and makes them spin. The device then measures how fast they're rotating to give an exact reading of the wind speed.
So, we have learned so much about wind today, how it forms, its different types, and how we measure it. I'll leave you with one final question to think about. This power that we can measure, how can we best use it for our future, for things like renewable energy? How can we harness this force for good? Something to ponder. See you next time.